question that will be answered today. Just record this and so that those who missed out can catch up. So we have Jimmy swinging around, and so this is quite typical trig modeling question. We understand for this case the height of Jimmy when he's on swing above the ground and can be modeled by a sinusoidal wave. So either sine or cosine will fit in over here. So let's have a look, and if assume that Jimmy, for the first picture that you have, is the highest above the ground. So the height from here to the ground is 2 meter. Right, 2 meter. We understand that Jimmy will go down, let's go lower. The distance from the highest place, of course, is the maximum. So this is, we understand, is going to be the maximum. Okay. Because Jimmy naturally will go backwards, from the place for this position that he's really in front, right? He's really in front of the swing, right? If this is a frame, that's he's in front. So he's naturally is going backwards. When he end up in picture number 2, okay, so that will be, have a look. So the height above the ground is only 1 meter. So I'll say this is the lowest it can go, right? When he play on the swing, unless he fell off, right? Otherwise, the distance for him to the ground will be a minimum for this case, right? Will be 1 meter. So if you further continue with the momentum, we understand he will swing backwards. So this is really the back position, right? So because he is at the back of the swing physically. So the distance, I'm sure you can see that. Okay, the distance from this point to the ground is also going to be 2 meter. So he's swinging in front of the swing and at the back of the swing, and all reach to the highest point. The distance from the highest point to the ground is 2 meter. So this is also a maximum, right? This is as high as can go. So if we actually draw out, and assuming this is the t equals 0, right, when it start recording, so at the start is going to be the highest. Let's use red color, so the highest over here. So so for the second, green one, for the second, blue one, sorry, not colorblind. And for the second one, so after a certain time, it's going to be the lowest point, right? Reach the lowest point. Let's say, so this is 2 and this is 1. And then you continue. I'll connect them into dots, into a line later on, right? We understand if you continue in the same amount of time from the maximum to the minimum, and it will raise him from the minimum to the maximum, will take him to the maximum. So so he'll reach the maximum again. So this is 2. Okay, there is extra information says, okay, 1.5 seconds that Jimmy is from the highest point in front of the swing to the highest point behind the swing, right? So basically, if I just continue with all that 3 dots, and if I connect them together, right? So which means from this point, and he start going down, right? Start going down. Okay. Now we do understand it's going to be a curve, and then start going back up, and then slightly slow down when he reached the maximum, right? So this is actually in front. This point, talking about this point, is really in front, and this point over here is at the back, right? At the back of the swing. Okay. So this time from here to here is 1.5 seconds. Okay, so it's really a 1 period, right? When he swing from the front and to the back over here, let's say this position over here, right? Doesn't look like, but it's interesting. Okay, and that's actually 1 period. So from the maximum to the maximum, that's give you 1 period. So let's have a look at the information we have. We're going to convert that into numbers. We want A, B, C, D. So we're going to start from D. Okay, D we understand since we have maximum and we have a minimum, and D will be the midline, right? Which is halfway between the maximum, which is 2, and minimum is 1, and that's give you 1.5. And then what is A? Now, if you have maximum and minimum, it's really the difference of maximum and minimum, and you half that, right? Okay, so let's give you 2 minus 1 and divide by 2 is 1 divided by 2 is 0.5. Okay, so what this means is you have 2 over here that is maximum, over here is minimum, and then the amplitude is from the midline over here, which is 1.5. You go either up or you go down, right? This portion is called amplitude. How far you go from the midline to the maximum, and how far you go from midline to the minimum. They give you the same value, 0.5. Okay, so we have D and we have A. We just discussed the period for this case is 1.5 second. Therefore, B should be equals to 2 pi divided by period, which is 1.5. You can leave as it is, or you can turn it into, no, we might just leave it. Okay, so for C, now because we assuming this one start from a maximum, right? The information will be provided, but for this case, we have to assume, so it start from maximum, so therefore the C is 0, is not shifting, because we will try to match with the cosine wave. We understand it's from maximum to maximum, and then precisely we start from the maximum and we end up at maximum for one cycle. All right, so A, B, C, D is done. So we have y equals to, for the case in A, 0.5. We understand we use cosine. B is 2 pi over 1.5, and then x, there's no c, and plus 1.5. Okay, so that's how you model this one. Be careful, one thing is about the period, is 1.5, is really swinging from the front, which is maximum, to the back, which is also maximum, right? From maximum to maximum, give you one period. So that's 1.5. Okay, thank you.